So we're continuing topic 2.2 and 2.3. So what we want to know about the above definition of derivative is that if we don't use the value c, but instead we use the variable x, so we're going to take that definition and we're going to put an x in for the c, we can now use this to find the general derivative at any point, meaning I could just find it in general and then plug values in, and then I could plug multiple values in and find multiple slopes. Another special note is the word derivative is a noun. Often directions ask you to find the derivative of a function as differentiate the function. Differentiate just happens to be the verb, and you'll notice that it says that. So differentiate and derivative are really the same thing, just one's a noun and one's a verb. The other thing we want to note is over here. It says think about it, and this is what I talked about earlier. Look at what happened. We just put the delta x in there where the h was, which we did stuff like this in the first unit. And remember, delta x just means that it's change in x. So really, how is the height changing? Or how is the h value changing is what's going on here. All right, so we're going to differentiate this first one. So we are going to follow this formula, and it always helps. Again, I'm going to use that derivative notation that we learned in the last lesson. So it's f prime of x equals, and I'm going to write this out because I am learning I'm working on trying to memorize this, minus f of x over h. So we have the limit as h approaches 0. And then I'm going to take the function and I'm going to plug in x plus h into the function. So my function is square root of x. I am plugging in x plus h. And then the second part says minus the function, which is square root, and then I'm going to plug in an x. And then this is all over h. In order to find this limit, this is of course a little bit more complicated than what we were doing before, but we did do this when we did the limits, is we have to multiply by the conjugate. So we've got the square root of x plus h plus the square root of x over the square root of x plus h plus the square root of x. So let's go ahead and simplify that. This up here, remember we set this up as the conjugate, so we only have to do f and l part of FOIL. So the square root of x plus h times the square root of x plus h would just be x plus h. We know that negative times a positive is going to be negative, and the square root of x times the square root of x is going to be x. And then in my denominator, I am not going to distribute. I am just going to write it the way it is. Okay, and then I'm noticing that I get to simplify my x's. So I have the limit as h approaches 0, and I wrote way too big. H over h times the square root of x plus h plus the square root of x, and check it out. The h's cancel. So we now have the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. Then I'm ready to plug in. So I'm going to plug my 0 in there. So I've got 1 over the square root of x plus 0 plus the square root of x, which is 1 over the square root of x plus the square root of x, which equals 1 over 2 square root of x, because there's a 1 in front of each one of those. So that would be the derivative in general on this one.